So there we go. This is really the code that I was demonstrating in this video. So there's this idea that you can create a fixture that essentially wraps around your test functions. They're much more powerful than using a utility function to just return you a client. You can, for example, clean up your client after your session has run. And in this case, this fixture has the scope of each test. So for each test, it creates a new transaction. And then after each test, it aborts transaction because this scope by default is set to prepare before the test and to tear down after the test. Hi, my name's Mark Smith and I'm a developer advocate at MongoDB. If you use MongoDB and you like to write your tests in Pytest, then keep watching because I'm going to show you how to use Pytest fixtures to run your tests against a live cluster and even to make changes to the data in your collections without leaving a trace after your tests are finished. In order to demonstrate building a test framework for working with MongoDB, we need some code that we're going to test. So I've already prepared a data access layer for some pirates. I thought pirates might be a fun theme to work with testing MongoDB interface code. So I have a file here called pirates.py. It contains a class called PirateDAL. DAL stands for Data Access Layer. So this is an object that in some way sits between our application and MongoDB itself. So it's the thing that connects to the database, sends the queries, interprets the results. It's really where all of our interaction with MongoDB would happen. And it means that we can change our schema in the database without necessarily needing to change all of our logic in the application. This data access layer provides a compatibility layer between what may happen in the database and what's happening in the application layer. My data access layer is very simple, really built for just demonstration purposes. I have an init method that takes a client that already exists. This means we can have several data access layers that all share a client if we want to. It gets the default database. It sends a ping command to MongoDB to make sure that the cluster is okay and that we don't get any nasty surprises later when we actually interact with the database. And then it gets a collection called pirates in there. So you can't see that because I've only got half the screen visible, but there's my pirates collection. That's called pirates. And then I make sure that there's an index in there on the pirate name field because that's the field that I'm going to use to look up pirates in the database. Then we have the standard create, read, update, and delete commands, a couple with funny names. So I've got new pirate, which takes a pirate name and then stores that away with some other data, including the pirate's favorite saying, which is always R. Then there's the read method, which is called getPirate. This just does a find one on the pirate name that's passed in. They have age pirate, which updates the beard color field to gray, no matter what it was before. And then we have murder pirate, which is our delete method that looks up the pirate by name and removes it from the collection. So this is a very straightforward data access layer. It's not doing any interpretation of the data. It's not doing any kind of mapping from the database schema into the application schema, but it gives you a good idea of what one of these classes may look like. The problem is, right now, there's no tests for this class. So we want to fix that. That's really what this whole video is all about. So I'm going to show you one more thing. We only have 3 files here at the moment, and only 2 of them are really important. I've created a PyProject toml. I'm using UV to manage all of my dependencies here. I know that UV is relatively new, so I will explain the commands that I'm running when I run them so that you can get a good idea of how that works. It works really well when working with Python projects. So all that's happened is I've given this a name. I've told it I want to build with hatchling, which is a popular default these days, or a popular choice. I've told Pytest that I have a source directory because I always like to have my source code under a source directory. And I've told Hatch both that I have a source directory and that my file is called pirates.py. If I didn't have that, it would be looking for a package directory called pirates with a double underscore init py file inside so that signifies that it's a package. So with that project definition having been written, I can then run uv run Python. So this will install all my dependencies, or it creates a virtual environment, installs all my dependencies into it. You can see it says installed 7 packages here in 8 milliseconds because they were cached. UV is super fast, if nothing else. And now I'm running Python with those dependencies installed. So I can do import pirates. And if we have a look in there, we should be able to see pirates DAL, which is over 2 lines here. So there we go. That's my pirate DAL object. So that just tells me that I kind of have a project that makes sense, right? That I can run code against my pirates object, that it imports okay. So now it's probably time to write some tests. So let's create a directory called tests, because that is what Pytest expects. This isn't going to be a basic Pytest tutorial, but we are going to kind of start from scratch. So again, I'll quickly explain what I'm doing as I do it. So I'm going to create a file in there called test pirates.py. So now I have this file. I have a strange way of working between using the terminal to create files. I just find it's a little bit faster and more convenient in many cases than working inside the point and click IDE in Visual Studio Code here. So now I have a test file. Let's create a dummy test. And this is just going to fail. I'm just going to put an assertion in here. So Pytest, unlike unit test, is very lightweight in terms of how you write tests. It tries to get out of your way. It will automatically detect any functions that start with test underscore and then call them. And you can use the standard Python assert that it uses in clever ways to test whether something is true or false, or works according to your test assumptions. So now if I was to run Pytest, it will pick up this test and then fail. I can't just run Pytest though because of the way that UV works. So I need to run everything through UV. So much as the same way as I ran Python above, I'm going to say UV run Pytest. And then it's going to run my tests, and I get an exception. It gives me a nice breakdown. It says that true is not equal to false, and I can get this to pass. If I test true equals true, or true is true would probably be a better way of working with Boolean. So that's great. My tests are working. So if I wanted to test some of my pirate code, I'm going to need a MongoDB client. Let me just get some code that I've already written here. I am going to test my connection to MongoDB. So test connection. This is going to be a duplicate of some of the code in my pirate object. So let me just hide the terminal here so I've got a bit more screen space. I need to import Mongo client. And I need to import OS. The thing about configuration tests is they don't just run within Python. They test the interaction between 2 different systems. In this case, it's MongoDB and my Python code. So I need to configure it with how to connect to MongoDB. I like to do that through environment variables. You may have a preferred way of setting up your integration tests, but in this case, in my test, I can just expect this variable to be available. That's one of the requirements for running these tests, is that you set this variable beforehand. And that environment variables are nice because they work with a bunch of different tools. You can store them in .env files and then load them using various different tools, or even the python.env library. So it gives you a lot of choice as to how you configure that data and provide it to your test code. I can set up this client object, and then I can just call my ping code that I had up here. So raising an exception is a valid thing to do in a test if it doesn't work. So I'm just going to change this to a sort of standard exception, and then client. MongoDB clusters will always have a database called local, so I can just run my command against that. It doesn't matter what database I run this command against, as long as I have the appropriate permissions. So this should work. And we know that it's calling our functions, so let's just let it run our tests. And there we go. So I know that my connection to MongoDB is okay. Now, if I wanted to initialize my PyrateDAL object, I could do that here. I could import pirates. I can instantiate my PyrateDAL object. I can pass it my client. It's going to test that connection now. So I can probably get rid of this code. Ideally, I'd have a test to make sure that it does fail when the connection doesn't work. But we're going to be running some things through the DAL anyway that won't work unless we have a valid connection. So I can worry about that later. Let's just check that this works again. Oops, excuse me. I use my inbuilt terminal. So there we go. I've run my test there. So I can create my DAL. The thing is, if I'm going to be creating about 4 test methods, maybe more. I'm going to be calling, I'm going to have test get pirate. And I'm going to have test init and test new pirate. And these are all going to have the same boilerplate code. So they're all going to set up a client, they're all going to set up a DAL, and if I change the interface for doing that later on, this is a lot of repeated code. And one of the things I could do is I could create a helper method in here. So I could call it get client or get DAL, get DAL, and just return that DAL object. But there's a little bit more to it than this. In fact, let me work with this for the moment. So because this doesn't begin with test underscore, it won't be mistaken for a test function. It won't be called by Pytest. But one of the things that it is doing that isn't ideal, so this is the equivalent of what we just had, but it is creating a new client every time. And what we really want to do is share clients across a session. Let me just demonstrate how that's working by sticking in some logging messages in here. Let's import logging up here. Actually, you know what? I'm going to do from logging import info. And then I am going to just print out a message here saying client init. So now, if we run the tests with the correct flags, I will see that log message appear a couple of times. So let's do that here. I can't remember the exact command, but fortunately I have it hidden in a just file. So if I run just test, it runs it with these 2 flags that mean I can see the log as it's printed out. So here we have client init and then client init. So we're actually initializing Mongo client multiple times, which is not something we want to do. So we really want this to be happening via a session. So we can use fixtures for this. Fixtures is a way of providing reusable objects, often data, to different test functions that it can then use to execute its tests. In this case, we're not providing data, we're providing the interface to a database. And you would instantiate one of these, you make it a fixture by sticking Pytest fixture in front of it. So there we go, that's a fixture. And the way that this would then be used is that we access it by name here. In fact, not get DAL, excuse me. We'll just call this DAL. So I can just put in a little test here that we're actually getting provided a DAL. I can also log what the DAL is. So let's run these tests again. There we go. So client init, and there's my PyrateDAL object. That's what we expect to see. And it's done by each time a test is run, it calls this function and uses what's returned. So how is that different from a helper method, except for the fact that it's passed in by this kind of magic? Also, it's worth noting you should never keep your fixtures in the same file as you're using them. It's very easy for you to forget to put this tag on, and then you end up with a function being passed in. It's very error prone. So we put these in a global test config file called conftest. Oops, excuse me, I have failed to autocomplete. So now, if I put that in the file that I just created, conftest, I can delete this too. I know this starts to look like magic, and that is because Pytest is very magic, but it is kind of the good kind of magic where it makes your life easier once you understand how it's all working. So I need some imports here from logging or info. Also going to want this to be imported, and we're going to want this to be imported. So just let Visual Studio Code do its job. Now, if I run just test again, run Pytest, there we go. We've got client init, and we've got this fixture code, which isn't really the test code. It's out of the way now. It's in a completely different file, but it's still being initialized each time. If you look at this log, for the new pirate, it's calling client init, and for get pirate, it's calling client init. So we can change that by changing the scope of the fixture to session. So now, when I run my tests, it's initialized as part of the setup for the first test that it runs, and then at the end, it never calls client init again. But then there may be some more cleanup code that we want to do. So this is great for providing data, but often there's a setup and a teardown stage. But fortunately, fixtures are designed to deal with that too. So instead of returning pirate DAL, I can yield a pirate DAL. Yielding means that this function is still can be resumed. I can stick more code after this and it will be executed, providing Pytest asks it to be executed. So here I can do a client.close if I want to. And that's just a nice way of cleaning up. And I'll stick an info message here to say that the client has been cleaned up. And now, if we run Pytest again, there we go. We've got client init at the start, client cleaned up at the end, and then a couple of tests run in between, executed in between. So that's great. That is the behavior that I want from a database connection. So that's a good start. And that also gives us, this gives us the DAL to deal with. So here I can test new pirate, I can test get pirate. Let's test that the database is empty first. But first, it's worth noting that by adding type annotations, you can really help out your editor with knowing what types are being passed around. So there, now it knows that the DAL is a pirate DAL, even though it's being passed in by magic by Pytest. So I'm not testing that there are no pirates. I'm just testing that this pirate called Jim doesn't exist, because this is a pirate that I'm going to be using in a lot of my tests. And I want to make sure that at least one of the tests is making sure that the database's clean state is actually clean. So let's run that test and make sure that Jim is actually none. So here's my tests. And there we go, it passed. So actually I'm not getting a pirate called Jim back from the database. That's great. So now let's test creating one. I'm going to take out my info message. I'm going to call dal.createPirate, new pirate, excuse me. And I'm going to pass in the name Jim. And then I'm going to call getPirate again to just assert that it isn't none. In fact, I'm going to test that the pirate name is Jim. So just making sure that it's coming back with the right data from the database. So now let's run this and we get a failure. So what's interesting is we had one pass, which was the function I've just written, new pirate, and then we get failure with get pirate, because this is expecting Jim not to exist. But if I connect to my database, and I'm using the MongoDB Visual Studio Code plugin for this, if I connect to my database and just refresh what's in that collection, I have this item called this pirate called Jim in here. That's the one that was just created in the first function and is not being cleaned up afterwards. So this is going to be a problem. So let me delete that document while I'm here. I can delete that just in this interface. There. Now, I need this pirate to be cleaned up after it's been created. This is going to be the problem with any test function that modifies data in the database. So what I need to do is run this within a transaction. So I can create a fixture to do that. If we go back to my previous fixture, this fixture does some setup by creating a client, and then it does some cleanup by closing that client. I can create a similar fixture that isn't session scoped, that creates it sets up a transaction, and then it rolls back or aborts the transaction after it runs the test. So let's have a go at that. Okay, so here's the fixture I wrote earlier. And first I have to get hold of the Mongo client object that's inside the DAL, and then I call start session on it because I need a session object. This is the thing I'm actually going to yield in the middle for the test to use. Then I'm going to start a transaction by calling start transaction, and then I'm going to yield that session object that's now in the middle of a transaction. And then afterwards, no matter whether the test function returns normally or whether an exception is raised, I'm just then going to abort the transaction. So it's never committed. This is not normally the way you'd use a transaction in user code when it's not test. You would usually use a with statement for start transaction. And then outside that with statement, if your code inside the block completes normally, everything will be committed, and it'll only be aborted if an exception is raised. That's a more normal way to use a transaction. But obviously in this case, we want to use this for cleanup every time, and so abort transaction is all we ever want to do after the code's finished. So now that I have this fixture, let's try using it. So I'm going to pass that in to test new pirate, and then I have to pass that into new pirate, and I have to pass that into get pirate. So as long as I'm in this transaction, as long as I want to stay within this transaction, I need to pass this session object in, and that guarantees that that everything's done within this transaction that will be aborted. So here I don't need to actually assign that to a variable. I can just say pirate assert, pirate name is Jin. And now, if I run this code, everything passes. And if I check the documents in the pirates collection, I still got no documents. So that means this new pirate that I created was rolled back after the test was complete. But within the test, if I call get pirate, then I get back my object that I just created. So I can use this to create a handful of tests that test all the different aspects of this DAL objects. I can create a test that does a better job of creating a new pirate. Now I can use this client session type annotation here that again just kind of helps me write my tests because it knows now what a session is. It knows that's supposed to be passed in there. And then I can check that when I create the pirate with all the defaults, it's created with the correct favorite saying and the correct beard color. So if I run that, it works. And then I can test deleting or aging a pirate. So let's test the murdering a pirate. So here we go. So I pass my rollback session in, I create a new pirate, I check that the pirate exists, that it's not none when I get it back from the database, then I can remove it from the database, and then I can ensure that Jim is none when I request Jim's data from the database. So there we go. This is really the code that I was demonstrating in this video. So there's this idea that you can create a fixture that essentially wraps around your test functions. They're much more powerful than using a utility function to just return you a client. You can, for example, clean up your client after your session has run. And in this case, this fixture has the scope of each test. So for each test, it creates a new transaction. And then after each test, it aborts transaction because this scope by default is set to prepare before the test and to tear down after the test. So I hope you found this video on using Pytest with MongoDB useful. Really, the whole point of this video were these two fixtures that I find myself using all the time. One that's session scope that manages my connection to the database, and the other one that wraps each test that needs it with a session, such a transaction that will be rolled back at the end of each test to allow me to make modifications to the database that then automatically and thoroughly get rolled back within the database. There are other approaches to testing your database access layer. There are, for example, libraries out there that will pretend to be a Mongo client. And so you can still call all the same functions for querying and updating on these libraries, but they just return you dummy objects that don't actually interact with any database at all. And those can be kind of useful if you just want to validate that you're making the function calls that you think you are, but then can't be a replacement for actually executing queries and updates against a real database and then observing the changes that they make and validating that those changes are correct and that the data being returned from your queries is correct. So you may not want to use this for all of your tests. It can be slower than other approaches, but it's certainly a useful tool in your toolkit for working with MongoDB. That's all I have for now. Hope to see you again in the future. Bye.